In this video, I'm going to be introducing area and this concept of Riemann sums. So our whole goal for most of this semester is to find, I don't know why it's not clicking through, there we go. Okay, find the area under the curve. So if I wanted to find this area, I wonder how we might do that. And we actually had an activity that we did at the beginning of the year where I think I asked you guys to draw in some rectangles. And we draw in rectangles. And using these big rectangles, we're going to approximate the area. And I wonder if I made these rectangles infinitely small. So maybe I cut these rectangles in half. I made them even smaller and smaller and smaller until I get basically the width of my pen here to get the area under my curve. So this is what this lesson is kind of setting up for us. It is a pretty hefty lesson. There is a lot of algebra that is expected in here. But I'm going to go through some examples and show you guys what my expectations are. Okay, so this first example, approximation with Riemann sums. So Riemann sums are a way that we can approximate by using rectangles. And there's a few different types of rectangles we can use. We can go to the left side of our interval. So looking at each one of our rectangles, we go from A to B, and I break this up into n rectangles. So that's my number of rectangles. And if I'm going to the left, I look at the left endpoint of each one of my intervals. So I split from A to B up into a certain amount of rectangles, and I start at the left endpoint and start drawing my rectangles and finding my width, which we're going to be calling delta x, times by my height, which is my function value. Okay. Now, if we were going to do the right side, so I look at my interval and I go, so instead of looking here, I'm going to be looking to the right. So I go to the right endpoint of my interval. I draw up my height to draw my rectangle. Now the midpoint, that's even more fun. I go to the middle of my interval. That becomes my height, and I draw my rectangle. Hopefully this will become clear with my first example that I do. Okay, so first example. We want to do a left, right, and midpoint. Okay, and I'm going from 0 to 3. So our delta x, which is going to stand for our width, we take b minus a and divide it over n rectangles. So I have 3 minus 0 over 6. So my width of each one is 1/2. So each one of these is going to be a half unit. Okay. Now if I'm doing left, so here's my first interval. Let me highlight that for you. Here is my first interval. I go to the left point of that interval. I draw up my rectangle. Oh, I draw up my rectangle. I'm going to redraw my rectangle. I apologize. That's going to cut into some time. So I go to the left point of my interval. And I draw my rectangle. And then I go to the left point of my interval. Draw my rectangle. Left point of my interval. Draw my rectangle. Left point of my interval. Draw my rectangle. And I continue going along and drawing my rectangles. Okay, so we're going to find the area of each one of these rectangles, add them up, and we're going to say that that's the approximate area under our curve. Okay, so my width, we found right here. That was 1/2. The height, my first height here, well, that is my function value evaluated at 0. Next, I have my next width. 1/2. And I have my function evaluated at 1/2. And then I have my next interval, 1/2, with my function evaluated at 1. And I continue going since I should have n equals 6 rectangles. F of 2.5 times by 1/2. Okay, so I find what all these are in my calculator. I sum it all up, and I should get 20.125. I have a little hint, I have a little reminder to myself down here. Is this an upper or lower approximation? Well, look at it. All of my rectangles are above, so this is an upper approximation. Because my graph is concave down, decreasing, we're going to be an upper. Next, we have our right intervals. So I have the same intervals, but now I'm going to have different rectangles. So at each one of my points, each one of the intervals, I'm drawing my intervals in on the bottom, I go to that height. That's now, the right point of my interval is now my height. And then here I technically have no rectangle. So my delta x actually remains the same. So I have 1/2. Now I start with f of 1/2 is my height. These are all standing for the heights, just so everybody realizes that. F of, now I have this height, f of 1. F of 1.5. So now I sum all those up, okay? And I'm using my calculator to find these values. If you didn't have a calculator, I would give you something like 3 rectangles and they would be nice function values. So my right should be 15.625. Now upper versus lower, okay? I'm still decreasing concave down. This was a lower approximation. So now my midpoint. So now I go, 6 rectangles. Marnell, you're killing us. 6 rectangles. I go to the midpoint of the interval. So I go to 1/4. That's my height. I draw my rectangle. I go to 3/4. That's my height. And so I actually like midpoint. Midpoint probably has a little bit more complicated numbers for us. But notice how some are above and some are below. So again, our delta x, or our width, is still 1/2. So I still have this 1/2 f. Now you go halfway in between your two endpoints of your interval. Halfway in between was 1/4. 1/2 f of 3/4. And I continue on 1/2 f of 1.25 plus f, I'm going to write this actually as 1/2 f of 1.75 plus 1/2 f of 2.25 plus 1/2 f of 2.75. And so then now calculating this in my calculator, 18.0625. And notice how that was in between my two other values. And I shouldn't have this lower versus upper approximation sitting here, okay? Okay, one last thing I want to talk about with us today is our left versus right and our approximations. Okay, so let's say we have here, so this is where my curve is. These are where my axes are. I'm going to draw in some axes for us because I'm just looking at this right now and I know I'm going to confuse myself if I don't draw in my axes. Okay, so let's draw in that's not going to do what I want to do. Okay, so if I have here a left point, so let's divide this up into 3, 4. So if I have my left endpoint, there's one rectangle. Left endpoint, there's another rectangle. Left endpoint, left endpoint. So this was increasing, concave down. My left endpoint was an under approximation versus now if I go to my right endpoint, go to the right endpoint of each one of my intervals. Okay, that's going to be an over approximation. And we can do that same thing with each one of these. To save myself a little bit of time, I'm going to do 3 intervals because I think we could see it with 3. So this one is decreasing, and that one's concave up. So my left intervals, again, look like they're going to be over. Versus now my right are going to be under. So now here, let's go to this one. This one is decreasing, concave down. And let's draw in our rectangles. So let's draw in, I'm going to draw in 3 just because it's easier. Left, looks like they are over. And then my right, hopefully you get the idea that you have to talk about concavity and whether you're increasing or decreasing in terms of whether, so if I notice decreasing, actually let's come up with some hypothesis here. No, I'm going to wait and do the last one. I apologize. I'm all over the place. I hadn't really thought of how I was going to teach this. Okay, so again, I have my 3 intervals, my left endpoint, my left endpoint, my left endpoint, versus, and those look like they're all under, my right endpoints, look like they're going to be over, and this was increasing, concave up. So let's look at these. Okay, where am I under? Where is my left under? My left is under whenever I'm increasing versus now whenever I'm over, we're decreasing. So it looks like it has to do with just increasing. I threw in the concavity there because I wanted to see if there was a correlation, and I don't think there is. So now my right, again, we're over whenever we're increasing. So it looks like it has to do with under when we were decreasing. So it has to do with increasing, decreasing. There's no correlation between the concavity. When we get to another type of approximation, that will deal with concavity. So that is your introduction to Riemann sums and rectangles and all that fun stuff.